Dear friends, Maths Aspirants is a collective of students, teachers, research scholars, initiated by myself in 2017, and we used to organize several online programs like online problem solving sessions, invited talks, webinars, test series, etc. to help the students who are preparing for different national level competitive examinations, apart from providing a discussion platform for higher mathematics. Today, we are having a session on especially focusing on IIT JAM examination on the topic ordinary differential equation. We blessed to have Ms. Unnati Shukla as the resource person for today's session. So I welcome everyone to this program on this auspicious National Statistics Day. I'm very happy to introduce Ms. Unnati to all of you. Ms. Unnati is an active contributor of Math Aspirants groups. She did her MSc from Maharshi Dayanand University, Rohtak, Haryana, and cleared different national level examinations like JAM, NET, GATE, etc. with good ranks. And she did M.Tech in data analytics at IIT ISM Dhanbad. Currently, she pursuing PhD in IIT ISM Dhanbad. So I'm sure that today's session will be really helpful in your preparations for IIT JAM examination. And the class may be useful for other those who are preparing for other exams as well, because OD is one of the core parts. You can expect questions in almost all these type of competitive examinations. I would like to express my sincere gratitude to Unnati for being with Math Aspirants, and I welcome everyone to this program. Welcome, Unnati.
Thank you so much, sir. It's been a great pleasure again to come here and interact with students and teach them. It has always been fun to me. Another thing I want to say, sir, that without your initiative, it wasn't possible that we gather together and share our knowledge. So thank you so much, sir, for this initiative of this community. And let's get going into the session. Without any further ado, let's get started, everyone. Hi, everyone. Unnati here, and today we are going to start with the ordinary differential equations, which is the main motive of our today's session. Let me just give you a brief overview of what we are going to cover today. So as we are focusing on the next year's exam 2026, I've just taken all the questions of differential equations topic related to the exam, all the questions that were asked in the 2025 exam. So basically all the questions of IIT JAM 2025 asked by IIT Delhi. And here you can see, just a minute. Here you can see the syllabus. So this is the syllabus. If anyone wants to take any screenshot or something, they can. So after this session, if you ask for the PPT, I'll be sharing the PPT with you, which will have the solutions and the list of questions in that. So, okay, let's get going. So we'll be solving around 10 questions and very easy questions. I won't be solving fully because we are, limited in time. So I have also included the, type of the question, marks given to the question, and negative marking that was there in the question. So you don't need to worry about, that thing. And also one more thing I want to tell you is that these questions, concluded about 17 marks in the exam. So 17 marks is very good to, get a good rank or, change the game of this competitive exam. And also the questions are not very difficult. They are from easy to average to bit of hard questions. We'll see all those questions. So, okay, let's start without any further delay. Okay, this question says for which one of the following choices of nxy is the equation, this particular equation is exact. So you know any equation of this type,
Unnati, is the screen changes? I think.
Yes, it should. What is it showing, sir?
For me, yeah, now it's okay. Now it is question 2.
Okay, so this is the problem with PowerPoint. Let me open it in Edge. No issue.
Okay.
When I do the,
Yeah, now it's okay.
Thing, it doesn't show.
Now it is okay. You can go with.
Just a minute, sir. I'll have to open it in Microsoft Edge. Sorry for that, guys. Just a minute. Okay. I think, is it?
Yeah.
It is.
Yeah.
Okay.
Right.
Thank you, sir. So here is the question. So this is the first question. This is of MCQ type asked in the exam. This was of MCQ type, 1 mark, and negative marks was 1/3. And very easy question. You know, any equation of type m dx plus n, which is a function of xy into dy, is equals to 0. This is exact if and only if the partial derivative of m with respect to y is the partial derivative of n with respect to y. Both are equal. And this is a very basic question. I don't think I need to solve this. Once you will solve this, this part will be m part. And this is the n part, which you need to find out. So this condition can be used to solve this question. This says that the partial derivative of m with respect to y you need to find out. If you find it out, it will be, yes?
This will be del n by del x. Del n by del y equals to del n by del x.
Sorry, okay. My mistake. Thank you. So this will be e to the x cos y minus 2 sine x. This will be something like that. And for all these n's, you can just find out their partial derivatives with respect to x, and you can check if they are equal to this del m by del y. So clearly A option is not there, because if you derivate it with respect to x, you won't get cos y here. So no. So B option says ex cos y. Let's try to do it. Partial derivative with respect to x will be e to the x cos y. Okay, first term matches. And partial derivative again with respect to x in this term will be minus 2 sine x. So this is equal to this. I mean, the nx thing, the partial derivative with respect to x is equal to this. So this means that B option is correct. As B option is correct, and this is an MCQ type question, so option C and option D cancels out. So basic discussion of this question yield us a very simple answer. I hope this is clear to you. If you have any questions, right away you can ask during the session. And if you have any questions that are not related to the problems, you can ask them by the end of the session. So let me move on to the next question. So question second, which was question number 5 asked in the question paper. Just a second. I don't know why it hanged, but okay. So the question is, which one of the following is the general solution of the differential equation? So differential equation seems like a differential equation with constant coefficients, and there is something on the right hand side. So this is a non-homogeneous differential equation of non-homogeneous differential equation with constant coefficients. So how do we solve it? So first of all, you need to figure out what will be the auxiliary equation. I'll write it in, in very short. So this will be d square minus 8d plus 16 is equals to 0 will be the auxiliary equation. And this clearly says that this is the whole square of d minus 4, right? This will give you two roots, 4 and 4. Okay. So the general solution, the complementary function part will be, so the CF part will be C1 plus C2 times x, as these are repeated roots. So I will write e to the 4x. So let us see C1 or C2 or alpha 1 or alpha 2. These are just arbitrary constants. Let me match the options. Okay, e to the 4x is there. These options will never match because they have given -4 as the root. So I'm going to cancel them out. So you see, as I proceed, my way of solving the question is, as I proceed half of the question, I look up to the options so that I can just, free my mind by canceling some of them. So this is my approach of solving the questions. You can just solve the complete question and then look for the options. That's completely your choice. However, in whatever way you find it easy. So let me just find out the particular integral. This is again a very easy question. So let me just do it fastly. 2e to the power 4x is there. Okay. So now let us figure out how to solve this. So first of all, you see this e to the 4x, but you can do it with two ways. Case of failure way. The case of failure way is there because if you substitute d is equals to 4, you are going to get case of failure, not just one, but 2 times. And there is one more way to solve this. That way is the shifting property. Let me just solve it by shifting property first. So when you have exponential here, you can just shift, this whole polynomial that is given to you in the denominator. How do you do it? Whatever coefficient you have in the e power, what you do is you just add that coefficient. So let me do it and then show you. You put e to the power 4x here on the right hand side. You shift this polynomial by 4 and rest of the thing stays same. So what happens here is it becomes e to the power 4x 1 by d square of 2. And as you know, 1 by d is the integral thing. 1 by d square is double integral. So when you integrate it first time, you're going to get 2x. And when you integrate it again, you're going to get x square. So this whole thing becomes x square. This is e to the power 4x. And the answer you get is e to the power 4x into x square. Very easy. If you want me to solve by case of failure way, I can do that too. But that should be your homework, I guess. So I love this one, the shifting thing, because that made the question very easy. So when you are solving a question in the exam, what you must consider is whatever way you are going to opt for. Like I opt for the shifting property thing. Whatever way you are going to opt for should save your time and should look easy to you. Okay. So if I would be sitting in the exam, I will opt for this. Although both methods are just going to take the same time, same amount of time, but I find it easy. So which option is correct? It becomes x square e to the power 4x. So I think option A is correct. Yeah. Okay. So option A becomes the correct option. Option B cancels out. Okay. Okay, now let's move on to the next question. This is the third question in the row. And this question is related to orthogonal trajectories, as we can see. I hope everything till here is clear now. So let's solve this question number 11 asked in the exam. Let C denote the family of curves denoted by this. So there is a family of curves. So whenever we talk about a differential equation, there is always a family of curves. Any solution to a differential equation is never a single function. It is a family of curves. For example, if you solve dy by dx is equals to, let's say, 1, what do you get? You get y is equals to x plus c. So this is a family of straight lines. So related to any differential equation, you always get a family. And what this c is called the parameter. So here c is taken to be lambda. So lambda is a parameter for your family. So if you have a family of curves, you can always find a differential equation. Okay, clear to us? And lying in the first quadrant of the xy plane, okay, so that means x is greater than 0 and y is greater than 0. Okay, let O denote the family of orthogonal trajectories of this C curves. So, you know, whenever you need to find the orthogonal trajectories, and they're in this question, they're asking you to find the orthogonal trajectories of this particular family C that passes through point 21. So this will be a specific function because it's passing through a single point. This will not be a family. Rather, this family will convert into a single function because they have given you a single point. Okay, so very simple, but asked in a very, formal way. But let me do one thing. If you have some family of curves, you can always find a differential equation, I said. But to find the orthogonal trajectories, what you need to do, you always know that you need to solve for dx by dy minus dx by dy, sorry. Because the family of orthogonal trajectories and the original family, their slopes product needs to be 1 because they are orthogonal, as we have studied in our school level math. That dy by dx, the slope of this original one, C's, and the slope of the O's, this family and this family. Any members of these families, their slopes multiplication needs to be 1. So that's why we are taking minus dx by dy. But to know what dx by dy is, we need to find dy by dx. So let me do that. So how do we do this? Y as it is, x square is, y as it is, derivative of x square, plus x square as it is, derivative of y. Y is dy by dx is equals to, lambda is a constant, so this becomes 0. So the differential equation ultimately becomes dy by dx is equal to minus 2xy over x square, which is actually minus 2y by x. Okay, now to find the orthogonal trajectories, the family of orthogonal trajectories, you will solve for minus dx over dy is equals to minus 2y over x. You just replaced dy by dx by minus dx by dy, and that's all. So I'm just going to use the method of separation of variables. So there are two concepts used here. First is orthogonal trajectories, and second is separation of variables, which is very simple. Let's solve it. So when I integrate both sides and solve for it, you know that I'm going to get something like this. But this is not my final answer. Although this can be. Hey, see, this right here is not needed. Why I'm saying that is because this is not our answer, obviously, because we have find a family, and our family has been find out to be x square minus 2y square is equals to some constant. So this looks in the form of x square minus 2y square is equals to some constant. This is not in that form. This is not in that form. So my answer is B. I don't need to solve for this 2, 1 point. I don't need to. Suppose they had given you some option, x square minus 2y square is equals to 1 or something, and B option would be this. Then you would be confused between the option B and option E. But here, you can clearly see no option is of matches this option B. So we need to, while solving a question, we need to do the minimum effort. And the minimum effort can only be attained if you are solving the questions and side by side you are looking for the options. Suppose you solve the complete question, put on the initial conditions, and then find the complete answer, final answer, and then you look for the options. That may waste your time. So I think the best way to solve any question is to solve it half and then look for the options, and then solve it, 70%, and then look for the options and then cancel them out. So, along with the question, judging the options and reading the options is also very important. So I hope this one is clear to you. I've spent a lot of time on this question. It was an easy one, but yeah, main motive is to make you understand. Okay, this question seems interesting. Can anybody tell me how to solve this differential equation? Just give me a minute. Yeah, can anybody give me a hint of how to solve this? I mean, this doesn't look like a linear differential equation, P and Q. Yes? Let me write this. Ln y. If anybody is interested or have the answer, any clue they can tell me. Otherwise, we'll solve it.
Homogeneous function in the form of y by x.
Okay. How do we do this then? How?
Ln y by x and bring the x to that side, then it will be in homogeneous form.
Yeah, interesting. So this question is very interesting, and I loved your answer. Thank you so much. Thank you so much. So you said we can use the property of logarithm like this. Ln y minus ln x is ln y by x. Right.
Yes, exactly.
This y and there is this x, right? And x belongs to 0 to infinity. X is not 0, so we don't need to worry about whether x will become 0. It can come in denominator or not. I can just do this. So now this becomes a homogeneous differential equation. Okay, so how do we solve a homogeneous differential equation? So we just need to substitute y over x by v. And when we solve it, what do we get? V plus x dv by dx. I'm so sorry. So you differentiate both sides with respect to x, y as it is. Minus 1 by x squared plus 1 by x is equals to dy by dx is equals to dv by dx, right? So you get minus y by x squared plus 1 by x dy by dx is equals to dv over dx. So when you solve for this and find for the value of dy by dx, what do you get is okay, let us solve that. Dy by dx is equals to y by x square into plus dv by dx. Okay, instead of solving this way, let me just make it easy. I'm just going to, well, all of you know what I'm doing, but I'm just doing for the sake of completing the question. Y is equals to vx, you just take derivative dy by dx. Here, when you differentiate with respect to x, you get v as it is, x1 plus v. Its derivative is dv by dx, and here is x. So dy by dx is nothing but v plus x into dv by dx. So let me substitute it here. So dy by dx is v plus x dv by dx. And on the right hand side, I have ln y by x into y by x. So ln v into v. Let us further solve this. I hope you are solving with me. Take your pen and paper if you haven't yet, because otherwise you're going to get bored. So when I take v this side, what will happen? I will take v common, and ln v minus 1 will be my right hand side. So let us solve for this. This becomes easy to solve by separation of variables. 1 by v ln of v minus 1. I think you all can solve this now. what I'm going to do is just substitute ln v minus 1 to be z. What will happen? ln v's derivative is 1 by v, 1's derivative is 0. So 1 by v dv over dx is equals to dz over dx. But you don't need x here. So dv over d is dz. Okay. So let us solve for this. dz over ln v minus 1. This part becomes z is equals to dx over x. So this is nothing but ln z is equals to ln x plus ln some constant c. So z becomes cx. I hope I haven't made any mistake here till yet. So z is ln v minus 1, ln v minus 1. And what is v? V is actually y over x. Okay, so this is ln y over x is equals to 1 plus cx. Let us now try to put the initial conditions, because without initial condition, you can find the answer. In this case, you can find the answer. So initial condition is when x is 1, y is e square. Let me solve it here. ln y over x is equals to 1 plus cx. So when x is 1, 1 plus c, y is e square. ln e square over 1. So this becomes 2 ln e. ln e is 1. 2 into ln e means 2 into 1. So 2 is equals to 1 plus c implies c is equals to 1. So our solution is ln y over x is equals to 1 plus x. Now you can just solve for y. Y over x is equals to e to the 1 plus x. And y becomes x times e to the 1 plus x. And they have asked you the value of y at x is equals to 2. So when you put x is equals to 2, what happens? So y becomes 2 into e raised to power 1 plus 2. So y becomes 2eq. Let's see if there is any option that says 2eq. Yes, there is. So B is the correct option. The problem that you may face with this question is you might make any mistake in solving the question, because that's a lengthy one, and that's why they have given 2 marks to this question. So if you make any mistake and that mistaken answer matches with any of the options, you will get in trouble, because you will get yourself, this negative mark of 2 by 3. So you don't want to do that. Be careful while solving the questions. Have a good practice and good command over this subject. Till now, we have seen, I guess, 4 questions, and 4 of these questions were easy. And right? 4 of these questions were very easy. So 2 plus 1 plus 1 plus 1. I guess you have scored 5 marks in the OT till yet. Okay. So this question says, there is a solution xi of this differential equation dy by dx is equals to y minus 1 times y minus 3, which satisfies that the solution at 0 gives you value 2. Means if y is the solution, then they say that this satisfies the condition y0 equals to 2, then which of all of the following is true? So they are not asking for the solution, rather they are asking for the limiting value of the solution. So I have a good way of solving these kind of questions without solving them. I hope you know the method of autonomous differential equations. Nowadays, the autonomous differential equations question is asked in every exam, be it GATE exam, be it JAM exam, be it NET exam. Earlier in the JAM exam, it wasn't asked, but from the past 2-3 years, I've seen that this question have been asked. So once you understand the method, if you don't know, it will be easy for you to solve these kind of questions. So autonomous differential equations is a kind of differential equation which satisfies this condition that on the right hand side, you only have a function of y, no x. And on the left hand side, I mean, this differential equation is of first order, first degree. But on the right hand side, you just have a function of y, which you can clearly see here. This is a function of y minus 1 into y minus 3. Okay. I hope I'm audible. Yeah. So how do we solve this? A graph will do it very easily. So for all of you who don't know about this method, if you have any doubt, you can ask me after I explain the question. Anyone said anything? So let us see the method. It says we want to know the equilibrium points for this system. What are equilibrium points? Whenever f of y is equals to 0. These are equilibrium points. Equilibrium means that the solution at those points is stable. So suppose only this differential equation was given to you and no initial condition. What would happen? How do you find very straightforward solutions to this question? Is there someone who is texting in the chat, sir? Is there any problem or something?
Nothing, I think.
Okay. So if this differential equation was given to you and no initial condition, very two obvious solutions for you would have been y is equals to 1. Because when I put y equal to 1 on the right hand side, it will become 0. And since y is equals to 1 is a constant, so constant's derivative is 0. So y equal to 1 satisfies the differential equation. Another solution anybody can guess like this? Hurry up. You can guess. Very easy. Another solution like y is equals to 1. How did I guess this y is equals to 1 kind of solution?
Y equal to 2.
Y equal to 3. Very good. So these are two perfect guesses if you weren't given this differential equation initial condition. But they have given you the initial condition, so you can't guess this way. But this guess is actually the equilibrium solution. I think someone's mic is on and I'm listening the noise. Okay, thank you. So, but this initial condition is given. It says at 0 it is 2. None of these solutions at 0 is 2. So obviously these two are not the solutions of my differential equation with this initial condition. That is very clear to us. But these are the equilibrium solutions. These will help us solve this particular solution, differential equation. So this is, let's say, y equal to 3. And this is, let's say, y is equals to 2. The initial condition says these two are equilibrium solutions, remember. The initial condition says that your solution at x is equals to 0 is 2. So your solution passes through this point. This point is actually y is equals to 2. And when x is equals to 0. So this is x-axis and this is y-axis. Your solution passes through this. Now, be careful. Now what happens? Now I want to judge the slope. Actually, I want to draw the slope field. If anybody of you have studied vector fields, it's okay. But if you haven't studied vector calculus or vector fields, that's fine. I'll tell you. See, at x, if you put y is equals to 2 here, what happens? 2 minus 1, 2 minus 3. This becomes something negative. I don't care what this value is, but I care about the sign of this value. So dy by dx becomes negative when y is equals to 2. So this means at this point, the slope field is going to go decreasing. Why decreasing? Because the solution y, your solution is going to go decreasing because the dy by dx is less than 0. Let me give you another example. It's, for example, if your y is equals to 3, what happens? sorry, y is equals to 4 at x equal to y equal to 3, obviously the slope is 0. So that's why you see solutions that are constant. But what happens when y is equals to 4? Let's say 4 is here. What happens? 4 minus 1, 4 minus 3 will be multiplied and they will give you a positive sign. So your slope field would look like this, increasing solution. So you will say, why do we care about the increasing and decreasing solutions? We do care about, because as your solution goes decreasing and decreasing and decreasing, it will never cross y equal to 2. Your purple solution will never cross your maroon solution y equal to 2, because that is a equilibrium solution. So y equal to 2 will act like an asymptote for all the solutions that are between y equal to 2 and y equal to 3. So your solutions go decreasing, and as x approaches to infinity, you see that your solutions which lie between 2 and 3, they go decreasing, and y equal to 2 acts like an asymptote. And you see and you observe one thing, that limit x approaches to infinity of my solutions between, when y is between 2 and 3, they become 2. One thing, this is you note. Another thing, they come from here. Where do they come from? They will never cross y equal to 3 also. They are packed between y equal to 2 and y equal to 3, because y equal to 2 and 3 are the equilibrium solutions. Equilibrium solutions again are the roots of the right hand side. So on minus infinity side, what will happen? These packed solutions from on minus infinity, as x approaches to minus infinity, y equal to 3 is going to act like an asymptote for these solutions. So what happens? At x tends to minus infinity, yx tends to 3. Let us see if any option matches our these two options. First option says infinity pe it goes to 0. It doesn't. It cancels out. I don't know about this option. Let me leave this. I know about this option. Yes, this option is correct. This matches my answer. So this is the correct answer. And I don't know about this also. But guys, note one thing. This is an MCQ type question. So multiple options can never be correct. Also, you can use some logic here that as ln approaches, x approaches to ln2, your solution may not go to this number, but I can't be sure about this. So as my first option, C option is correct, I can just say other options are incorrect. So you might ask, what if this question was asked in multiple select type? Then you may solve for this differential equation. So for your convenience, let me tell you, I solved this differential equation using partial fraction. And what I found was option B and option D were not correct. Okay. So for this case, you don't need to do that. Explaining me took like 7 to 8 minutes, but this is just a 1 minute thing. In under 1 minute, you can solve this type of question. And whenever they ask you this question, they never expect you to solve the differential equation. Mind that. They expect you to solve by solving the autonomous differential equation graphically. I hope this question is clear to you. If anybody has any doubt, they can just clear now. Then we'll move on to the next one. Okay. So I hope this one is clear to you. But if you're still left with any doubts, you can just ask towards the end of the session. Okay, let us see what this one says. This is also a good one. This may take 10 to 15 minutes. But yeah, an interesting one. And I have an interesting way to solve this question. It says, if m, n, mu, and w are differentiable functions with continuous partial derivatives satisfying this. So what does it seem like to you? See, it seems like this differential equation, m dx plus n dy is equals to 0. But this has some dw here, this has some mu here. So what is it? They are asking, let's read the complete question. Which of the following statements are true? And this is an multiple select question type, no negative marking. Mu W is an integrating factor. First option. Mu W square is an integrating factor. Second option. Third option says something about WXY. So you know, when you are solving for this differential equation, if let's say this differential equation is exact, okay, we will solve the question after I explain you this. Let's say this is exact. Then what happens? How do you solve for this? So one way I learned in my college, I don't know how you guys solved it. One simple way I learned in my college was to differentiate it with, integrate both of these, but with a condition, and keep it equal to a constant, but with a condition. And the condition was, in the first integral, y has to be constant. Y has to be treated as a constant because m is a function of x and y both. So y will be treated as constant. And in the second term, x will be 0, or let's say only those terms will be here which does not contain x. So I don't want x here. I just want the terms that are purely containing y. So let me be more clear with additional steps. Let me give you one good example. So let's do it with the help of example so that you can just, clear it in your mind. Let's say I have this differential equation, 2xy dx plus, let's say, x squared dy. So let me check if this is an exact or not. So actually I've taken an exact one. So del m by del y will be 2x and del n by del x will be 2x. So this is an exact differential equation. So in order to make this differential equation exact, you can multiply it with any integrating factor, be it 1 or anything. Because this is already exact. You can multiply it with any function. This will still be exact. Okay, so now another thing that I want you to note here is, if some differential equation is exact, let's say m dx plus n dy was an exact differential equation, then I can always write this differential equation in this form, in the form of an exact differential. So f is called the differential. Df is called the differential. So there exists some function f, whose, yes?
If I multiply by y, the equation, then will it exact?
Can you speak louder? I wasn't able to.
If I multiply by y, ma'am, then will it still remain exact?
If you multiply by y, you are saying like this.
Yes.
4xy, let's see. And 2xy. Okay, this is not exact.
Exactness will be hampered if we multiply by any
Yes.
random. Yes.
xy. Yeah. Okay, so this is a differential equation, exact differential equation. I got mistaken with the concept, but yeah. The thing is, let me erase this. The thing is, we don't need to consider that for now. I'll explain it to you later. You are right. So you multiply with some function, it won't be exact. Okay. So if some differential equation is exact, I can write this differential equation as an exact differential of some function f. So there exists some function f whose exact differential is this differential equation. So maybe here it says d of w. So w is like that function which we talked about just now, the f function, and this may become the exact differential equation. Okay. But if this differential equation, let's say, is not exact, then what you do is you multiply it with an integrating factor. You multiply it with an integrating factor. Let's say that integrating factor is mu, some function of xy, and again mu here. So if this is not exact, You multiply it with mu, you make it exact, and then there exists, this can be written as in the form of exact differential. So in both cases, you can write it in the form of exact differential. So one more thing, let's read the options. First option says, so mu w is an integrating factor. Since mu is an integrating factor, and this w is the function. We have a result in differential equations that this w, what is w here? W is the function that exists here, whose exact differential is equal to this differential equation. So if mu is an integrating factor, which clearly, if you are multiplying it with mu, this differential equation, so this means that mu is an integrating factor for this differential equation. For example, if this differential equation is exact, you can take mu equal to 1. So now, if this is not exact, you can take mu to be any function which makes it exact. So in both cases, mu is an integrating factor. It is clearly visible from this differential equation. So if mu is an integrating factor, mu w is always an integrating factor. W was this f function. But if you want to, you can always check this, but that will take a lot of time in solving the question. You can always consider this concept from your book. So these two options will be correct. W and W square these two options are correct. Okay. You can check whether or not they are integrating factors by multiplying them and then solving for, this whole part, the, del m by del ny thing should be equal to del n by del x. You can check that. So this will be true. Now let's come to the third option and fourth option. These look similar, but they have a difference. Let's read them. Wxy is equals to w00 plus 0 to x mu m s0 ds. They have put here y is equals to 0, and here t is taken as constant. This portion is taken as constant because they are integrating, x portion is, they are integrating it with respect to t. So that means this portion is taken as a constant portion. So x is constant here and y is 0 here. So remember I told you that you can solve it this way, but there is an alternative way to solve this too. How do you solve that? If you put m dx plus n dy, the alternative way is, because you can always do that, the differential equation is exact. So this one says y equals to constant. You can interchange it with, you can do terms not containing y. That means terms not containing y. Yeah, y is equals to 0. And interchange it with this condition with x is equals to constant. Okay. So here you see y is equals to 0 becomes this condition. I will show you with the help of an example. This might confuse you for now, but I will show you with the help of example what I'm trying to say. So these conditions can be interchanged. What I'm just saying is these conditions which I told you can be interchanged. So this option may be correct, but we'll verify it with the help of an example. This option is actually correct with this concept. But D option is not correct because they are taking the limits from 0 to x, fine. But here again, they are taking the limits from 0 to x. We can cancel out this with the help of an example. I took this example. Let's say, let me take this example, x squared dx plus y squared dy. Okay, this is a differential equation and we want to solve this. So how do we solve this? So if I put, so this is an exact differential equation. You guys can just, del m by del y and del n by del x, both will be 0. So this is an exact differential equation. So mu will act as 1 here. So if you want to check for option C, what you can do is just what you can do is just take 0 to x mu ms0 ds. 0 to x mu, which is 1, m, which is this, at s comma 0. S comma 0, it will be s square ds. Okay. And 0 to y, it will be t square dy. Sorry, t square dt. You can just match here. X will be constant here because as I have no term for x in this particular example, so I will put like this. So after you integrate, this becomes x cubed by 3, and this will become t cubed by 3, which is y cubed by 3. So this becomes your wxy. Your homework is to solve for this one, this example, 2xy dx plus, what was this equation? 2xy dx plus x squared dy. This is your homework. You can solve for it. But let me just consider why this w00 is here. Why this w00? I haven't talked about it yet. So suppose your function, this is your exact function, wxy you can call it, or you can call it f. Suppose your wxy was equal to x cubed by 3 plus y cubed by 3 plus some constant, let's say 7. Now if you put w00, then you get 7. So d of w should be equal to w00 plus, the rest of the two terms. W00 will be 7, and plus, after solving for these two terms, what I got was this, x cubed plus y cubed by 3. X cubed by 3 plus y cubed by 3. So then I will, sorry, d of w. I wrote here d of w. It won't be d of w. It will be w of xy. W of xy is equals to w of 00 plus whatever we solved for, right? We solved for this. So you will get w of xy is equals to this. So as you add a constant, you realize that w00 is very important. Why I'm telling you with the help of an example? Because the concept you can see in the book. But often what happens is, when you go in the exam, you are not brushed up with the concept so deeply. This question talks about the concept in a deep manner. So when we are not brushed up with the concept, we can take certain examples to help support us. So I took 3 examples. Let me summarize the examples for you. And summarizing the examples for you here. So example 1 was 2xy dx plus x square dy. Example 2 was x square dx. This is your homework to actually solve using these examples, because without examples, you don't understand the question. And example 3, I took something different. Wxy to be some constant plus exact differential to be like this, y cubed by 3. This was just to show you that w00 matters. Okay. Suppose there was an option which did not contain w00. Suppose your options would have been like this. W00 wouldn't be there. Then what would you do? You would have cancelled the option. So which one is the correct option? The correct option is C, because it has y here and x here. Both of these are x's here. You can verify. You can cancel the option D with the help of the examples that I gave you, or whatever example you wish for. Option D will cancel because we are short in time, so I'm not solving this one. You can easily solve and see that this will not work here. Okay. And in a gist, I can just tell you, if you go for option D, then that will give you, this limit will become x. And when this will become x, you will get x cubed by 3. And this is not what you want, right? So option cancels. Okay. I hope this question is clear to you. If any doubt is there, you can just ask. Otherwise, we'll move further.
Hello, Unnati.
Yes, please.
I'm Anubhav here.
Yes, Anubhav.
Actually, I'm struggling with the rate problems in application of derivatives. Anything in particular I should focus on, or any typical questions which can be asked?
Abhinav, this session is actually focused on ordinary differential equation for MSc level exam. I'll deal with your problem later.
Okay.
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 Okay. Thank you. We can talk after the session. No issues.
Okay. Fine.
Yes. Okay.
Thank you.
Okay, Abhinav. So let us solve for this question. This question is an interesting one, but yet again an easy one. What do you think the method that can be used here? dy by dx minus 2y to the power x, 2e to the power x root y. How do you solve this? This is not a linear differential equation, clearly. How do you solve for this? So any idea?
Bernoulli equation.
Yeah, this is Bernoulli's equation. This is the problematic part. So let me just divide everything by root of y, and I can do that because my y is positive. Always consider the domain and range because you don't want to be stuck in the concept problem. So I've just made sure that I can divide by y. 2 root y, it will become, because we are dividing by root y, e to the power x is equals to 2e to the power 2e to the power x. Okay. Now I will just give you. Okay, let's completely solve this question because this has multiple select questions. This might be difficult for you. So we are going to put what we are going to put actually. What shall we substitute? I guess if I substitute 2 root y to be equal to, let's say, v, what will happen? Its derivative, which is 1 by root of y, d of y, will become dv. Or I can say dy by dx, dv by dx. Right? I guess I'm correct here. So this part will become dv over dx. And this part will become, v. So minus e to the power x into v I'm writing is equals to 2e to the power x. Now this looks like a linear differential equation. So let's find out its solution. So the integrating factor will be e integration of p dx. What is p here? This is the p part. So this will be e integration of e raised to power x, negative e raised to power x dx. So your integrating factor will be e minus ex. Fine. So the solution will be v into integrating factor looks dangerous is equals to q into integrating factor dx plus c. Now how do you integrate? Can anybody tell me? How do you integrate? Actually, when you derivate e to the power minus e to the power x, without substitution, we can just directly do it. When you derivate it, what you get it e to the power x minus e to the power x into minus e to the power x, e to the power x, whatever. So actually, you got a hint that this thing will be equal to minus 2e to the, so the integration can be, if I multiply it with 2 minus 2, what will happen? Minus 2 will come here. So you see this part, sorry, plus 2 it will become. This will be the integration of this thing. 2e to the power minus e to the power x plus some constant v e to the minus e to the x. So v will become, as this divides on that side, this will become minus 2 plus CE to the E to the X. What was V actually? V was this, 2 root Y. 2 plus CE to the E to the X. Okay, interesting. Now let us put the initial conditions. X0, Y1. So Y is 1 when X is 0. Square root of 1 is actually 1. So X is 0. This means this is E. So 2 minus 2 is equals to C. What happened? I think I have made some mistake. 2 root Y, was it? 2 root Y, yes.
Minus sign.
It was minus 2.
Yes.
Okay, okay. So this becomes plus 2. So the C becomes 4. Okay, so now final solution will come from here. 2 root Y is equals to minus 2 plus 4 E to the power X. And this will be square root of Y will be minus 1 plus 2 E to the power X. So square root of Y. So what do we need to find out? We need to find the limiting value of our solution. Solution means Y. Okay. So Y becomes minus 1, yeah.
Minus 1 plus 2 E square, the whole square.
Is there any mistake or I'm going?
Just take
Correct.
E length.
You're not audible clearly. Y
Ma'am,
square
you just take
2E
limit.
minus 1. I guess we are.
Take limit, ma'am.
Yes, we can take limit. Y is equals to minus 1 plus 2 E to the power X whole square. Now limiting is value is limit X tends to ln root 2 or 2. It is ln 2. Okay. ln 2. Minus 1 plus 2. As X tends to ln 2, you know that
Square.
E to the X tends to 2. So this will be 2E square. It will become. So you want to find out 2E square minus 1 whole square. Is there any option? 2E square ln 2.
Ma'am, actually the constant value C is equal to 4 by E, right?
Okay, okay. This was the problem. I was thinking, is it not matching? 4 by E. So this will become E to the X minus 1. So there will be minus 1. There are some attentive students. Thanks to them. E to the X minus 1. So that means 2 minus 1. 2 minus 1 is 1. So this becomes 2E minus 1 whole squared. So the limiting value of Y becomes 2E minus 1 whole squared and not under root. So clearly cancels, clearly selected. So first option says this is an unbounded function. Our Xi function, the Y function was unbounded. Obviously it is unbounded. Why? Because E to the power X is unbounded. Again, this exponential function is unbounded. So unbounded you can check by taking limit X tends to infinity. As X approaches to infinity in this Y, in this solution, your Y will also approach to infinity. So you can check that. And this is also a strictly increasing function. Why? Because this is a strictly increasing function. E to the power something is also strictly increasing. So this is a combination of, or I can say a composition of strictly increasing functions. So this will be a strictly increasing function in this interval. So this option is also correct. This option is also correct. A, B, and D are the correct options. So you will get 2 marks if you got all of them right. But even if you miss a single one, you will not get any marks. So be careful with this MSQ part. Clear to everyone? If you're not satisfied, why is it strictly increasing? You can just take the derivative dy by dx, and that will be positive, and then you can check that way also. But since we want to save our time, so we will have to make some observations which I made here. Okay, so that's why I did this way. You can always check mathematically. So next question is a NAT answer type question, which is just of 1 mark. And this is a quite an easy one. I'll just give you a hint. I won't solve it fully. And you don't even need a hint, I guess. This is straightforward. 4d square plus 16d. This is your homework. If you face any doubt, you can always ask in the group. I'm there to tell you. This is your auxiliary equation, and you have just an auxiliary equation. You solve for the roots, you will get something like minus 16, negative 144, divided by 8. You will get minus 8 plus minus 12 iota by, minus 8 plus minus 12 iota by 8. So when you solve for it, you will get minus 8 plus 3 by 2 iota. And you know how to find the solution of this differential equation. That will be in the form of exponential and cosine and sine. So you know how to solve this. You've been given 2 conditions. You will solve for them and you can just find the answer. Its answer is actually square root of 2. Let's see if you can solve this. So this is your homework. But if you want to solve it here, you can do that. But let's move on to the next question. This is again a simple one. This question is of that I forgot the name of this type of differential equation. X squared d2y by dx2 x3y by dx. What was its name? Euler's.
Fuzzy legend.
Yeah. So in this case, what we do is x d by dx is supposed to be d, and x squared d by dx square is supposed to be d square. And knowing that, I'm just going to write it directly. The auxiliary equation. This will become, and remember that how this concept comes is by substituting x to be e to the power z, where z is equals to ln x. Remember this, because we're going to use this. So this complete equation will become, rather than the auxiliary equation, let us find the complete equation. So this becomes d into d minus 1 minus d plus 1 into y is equal to 6x. What is x? X is e to the power z. What is ln x? Ln x is z. So this becomes d square minus 2d plus 1 into y is equals to 6z e raised to power z. And when you solve for this, we'll get something like this. Okay, it is very easy to solve for the complementary function part. So let me write the complementary function. It will be c1 e to the power x plus c2 x e to the power x. Simple. But what about pi? Let's find out the pi. And again, I'm going to use the shifting property. Okay, how will I do that? Since I have 1 in the coefficient of e raised to power 1 into z, so I will shift this polynomial by plus 1. So this will become d minus 1 plus 1 into 6z, and this e to the power z will come on the left hand side. What will happen here? This will become 1 by d square of 6z. That means double integration of this 6z thing. So first integration will be 3z square, second integration will be z cube. So this whole thing will become z cube. And this is e raised to power z. So this is your pi. So this is your whole function. And please solve for this. Whole solution is y of z is actually in the form of z. So I will write this like this. Y of z is equals to C1 plus C1 plus C2z e raised to power z plus z cube e raised to power z, or I can write this as C1 plus C2z plus z cube e raised to power z. So since your x was e raised to power z, all those conditions are given on x, when x is equals to 1 and when x is equals to e. So remember, when x is equals to 1, z becomes what? Z becomes 0. And when x is equals to e, you can observe that z becomes 1. So the conditions can be transformed because I don't wish to change my solution to x now. I just want to solve it in z now. So I have changed the initial condition. So first initial condition is, I'm just giving you a hint, and then you can further solve this question. So my first condition in the form of z will become xi of 0 is equals to -3, where z is equals to 0, corresponds to this. And this will correspond to xi of 1 is equals to 0. So you put these two conditions in the form of z solution, and then you solve for it, and then you solve for xi dash 1. Very easy. I guess you can further solve it. Okay? Because we have some interesting questions coming up next. So I'm not solving it fully because this is a very college kind of differential equation kind of concept, very basic. Okay, so let us move on to this question. This question is an interesting one. Okay, this is the last question. This is the last question. Tell me one thing, guys. How do you solve for this? This is a linear differential equation. Let's try to solve it with the help of linear differential equation. But before that, I just want to do something because I am lazy and I don't want to solve this question fully. I just want to guess something, because in differential equations, I always find guesses easier than solving. So if you're sitting in the exam and you don't want to solve this, you can just guess the solution. How do you do this? See, one thing is very clear. Make it clear in your mind that this is an initial value problem. You might or might not have studied the initial value problem, but this is a differential equation of first order. Okay, this has infinite solutions, but you have been given a condition, initial condition. With a differential equation of first order with one initial condition, you can make sure that this must have a unique solution. And even if you don't know this concept, just use your head. If one solution is there, if there are multiple solutions that satisfy this system, then they won't give you a question like this. They won't ask you a value that is specific. They won't ask you for a single answer. They will ask you for multiple answers if this has multiple answers. So if I'm able to guess a single y that satisfies this, that means I've got my answer. So how do I guess? Okay, let me make a very simple guess. Very, very simple guess. Let me take y equal to 0. Okay, very layman guess I'm taking. Does y equal to 0 satisfy this equation or even this condition? Yes. First of all, let me see the condition. My y equal to 0 satisfies this condition, but my y is equals to 0 does not satisfy this. Okay, so that is a very bad guess, I guess. Y equal to 0 is not the solution. Let me take y is equals to 1. It's another bad guess because this doesn't even satisfy the differential equation. Can you guys make better guess than me? I'm bad at making guesses. Just help me out.
8 is 2.
Huh?
Y equal to 2.
Y equal to?
2x, ma'am.
2x or x square. Anybody? Any simple function. Okay, 2x seems nice, but let me just see if x satisfies this. So when I put x, what happens? dy by dx becomes 1 and 2x into y. Y is 2x, obviously. Sorry, x. Y is, I have taken x. I'm taking x. So this becomes 1 plus 2x square. But this is not equal to the right-hand side because right-hand side is 1 plus 2x square times 2. So this gives me some hint about a little better guess. What if I take y is equals to 2x? As someone of you said, y equal to 2x. 2x is a good guess, actually the perfect guess. When you take y equal to 2x, that will satisfy this differential equation. Because on the left-hand side, you will get 2 plus 4x squared. So out of all the random guesses, we have got our solution, which is y equal to 2x. So kudos. Congratulations, we've got a solution y equal to 2x. And y equal to 2x also satisfies this condition and also satisfies this differential equation. So when y is equals to 2x, y of 2 or xi of 2 will be what? Will be 4. And you got your answer. Guessing may take 1 or 1.5 minutes for this kind of simple equation, not more than that. But if you're saying that you want to solve this, you don't want to guess, let's just solve it. How do you solve it? dy by dx plus 2xy is equals to 2 plus 4x square. So if you find p, what is your p here? E raised to power x square it will be. So your solution will be y into e raised to power x square is equals to integration of q, 2 plus 4x square. 2 plus 4x square, sorry for the mistake, into e raised to power x square dx. Now you will have to integrate and find the answer. If you're good at guessing, then guessing will work for you. Otherwise, you can just solve for it. Don't go blindly for guesses. I'm not saying guessing is the perfect thing to do every time, but when you're stuck, you can just make guesses. So to solve this differential equation, know one thing. I'm giving you a hint. Again, I'm giving you a hint. I'm not solving this one. So dy dx of x e raised to power x square is what? X as it is, e raised to power x square's derivative is this. Then x's derivative, and then x's derivative is 1, e raised to power x square is this. So this is ultimately 2x square plus 1 into e raised to power x square. So your hint is, what if you differentiate this? What will happen? This is your hint to solve this differential equation. And yeah, that's it. When you will solve, you will get the same answer, that is y equal to 2x. And yeah, that's the, I'm up with the session. If you have any doubts, you can take. Yeah, sir. So I'm ready to take the questions. If you have questions related to any question we discussed, I will take them right away.
Madam, once you repeat about that equilibrium points.
Repeat about?
Equilibrium points.
Equilibrium point. Okay. Sure. So dy by dx, let's say, is equal to some y minus 7. Very simple equation. This is in the form of f of y. When you put f of y is equals to 0, the value of y that you get is actually a constant value. Okay, so that means that is actually a solution for your system. So y equal to 7 satisfies this system of equation. Okay, so y equal to 7, let me draw this. Y equal to 7 is somewhat here, let's say. So equilibrium solutions are always the horizontal solutions to your differential equation. Mostly as far as you are going to deal with, not more than that. So this is a constant value. So this value of y that you get is the solution of your differential equation, but not always. It is a solution of your differential equation as far as the initial condition is not given. In our cases, the initial condition was given, so the y equal to 1 and y equal to 3 solution were not accepted by me. So if the solution, they are the solution of your differential equation if just the differential equation is given to you, and let's say some condition is also given to you. Let's consider a condition that says y of 1 is equals to 7. Does your solution y equal to 7 satisfies this equation? Obviously. So the only solution to this differential equation in this case will be y equal to 7. And this will be equilibrium solutions. Whether or not it satisfies the initial condition, it will always be called the equilibrium solution. You can always call that. So in short, if you put f of y is equals to 0, the value of y that you get is the equilibrium solution. That's always a horizontal line. No solution above or below y equal to 7 can cross this. Suppose the solution is coming here like this, increasing, decreasing, whatever, it can never cross y equal to 7. Or if a solution is coming here like this, it can never cross y equal to 7. I use this concept while solving for that question. If you have any doubt regarding that question, I can go back to that question. I hope your equilibrium solution doubt is clear.
मैम इनिशियल कंडीशन क्या रोल प्ले करती है?
Actually, in what sense we are calling this solution as equilibrium solution?
Equilibrium.
Dy by dx is equal to 0. On that sense, you are telling it's equilibrium solution, or the right hand side value 0 means equilibrium solution.
Dy by dx is equals to 0 means equilibrium solution, because this is the state of no change. In that sense, we're saying.
Thank you.
Okay. Yes, someone else was saying something.
Yes, मैम इनिशियल कंडीशन क्या रोल प्ले करती है?
Initial condition क्या role play करती है? I can.
Suppose ये y 0 is equal to 2 था. Suppose ये 2 ना होगे 3 होता. Then कैसे एनालाइज करते हैं?
y0 is equals to 3 होता, or your differential equation would be like this.
Yes.
In that case, this is a very special case in which your equilibrium solution y equal to 3 and y equal to 1 was there. You know two solutions of this differential equation which are not the actual solutions because we'll have to see the conditions first. So let me say these are two equilibrium solutions. But they are saying that your solution at 0 is 3. Means your solution passes through this point, and the only solution that I can see that passes through this point is this horizontal line, and that means the solution of this differential equation is y equal to 3. So in this particular case, when your equilibrium solution satisfies the condition, initial condition, then the equilibrium solution itself becomes the solution. Y equal to 1 will not be the solution of the differential equation, will not be the solution of this system, but y equal to 3 is the solution of the system.
Okay. तो कोई भी हम लिमिट कहीं से भी आएंगे तो 3 पर ही आएंगे.
फिर से रिपीट कीजिए, कैन यू रिपीट?
मैम हम कहीं से भी आएंगे तो 3 पर ही आएंगे.
और भी कोई solutions होंगे, if there are any possible solutions, they will always act as,
तो ये
solution will always act as.
तो मैम ये 3 यहाँ पर काम नहीं करेगी. We have to solve the differential equation.
We'll have to call there.
We have to solve the differential equation in the English case.
See, अगर कोई solution, if any solution is coming from up this solution, y equal to 3, then this will be like this, or it can be like this. It can be like this, or it can be like this. So y equal to 3, the equilibrium solution which we are saying, has only one job, that it can never let cross the actual solution. Whatever solution are above or below it, it will never let it cross because it acts like an asymptote for other solutions. You may encounter more examples, and if you have any doubt, we will surely discuss. You can discuss it with me in the group also. Now, if you have any doubt, you can take them. And if you want, I can give you some practice questions for this topic. If this topic seems new to you, I will give you 4 or 5 questions in the group. Maths aspirants.
Yeah, that's good.
You can practice them, and if you find them difficult, we'll discuss them later.
Suggest some book for particular this concept.
From?
Any book you have for this concept?
For this concept?
Yes.
Actually, this is a vector calculus concept, but I think SL Ross also deals with this concept because let me be honest, I did not read this concept from a book. This was taught to me by a teacher, and then I looked into the vector calculus concepts. You look, I will suggest you looking for the vector field concept in vector calculus. Slope field or vector field. You search for it, you get very good online resources, or you search for autonomous differential equations, you will get some videos from outside India. They have nice content on it. We Indians, we don't read study slope fields as we are supposed to, but foreigners do. So you will get a lot of content on the internet. Okay.
Okay, thank you, Unnati, for this nice session with a good collection of problems.
Thank you, sir. Thank you so much.
Dear participants, it is a time to share your feedback, or if you have any query, you can ask it now. Feel free to share your feedback. Yeah, Preeti raised hand. If you have something to talk. Okay. So if any of you would like to share a feedback, please do it now.
Good evening, ma'am.
Good evening, Archana.
Ma'am, your class was really nice. I like the idea where you follow of canceling out the options because I also follow that method. So I always had a doubt whether is it the right way because most of them, like even though canceling out is an option, like they choose it for few questions. For most of the question, they directly go for solving it. So I felt this was easier than completely solving it, especially for competitive level examination, where time is important.
Yeah, this is actually necessary to do it this way.
Yes.
Because half of the question is written there and half of the question is written in the options. That's what I believe. So,
Yes, yes, ma'am. I really like that part. And ma'am, you actually explained even the minute concept, like in a question, even under that solving the in differential equation part and all, you explained it. Like it's a even though it's a small concept, you took the effort of explaining that small concept too, ma'am. That was really nice, ma'am.
thank you,
I
Archana.
really
Thank you so much.
enjoyed this
I
session.
hope it didn't bore you explaining
No.
the simpler concepts.
No, ma'am. It was actually refreshing, sort of like a small, a bit, the whole topic, somewhere it was there, but when you explained it, like you get it crystal clear, right? Like that, it was there. Thank you,
Okay.
ma'am.
Thank you so much, Archana.
Okay, thank you, Archana. Any others? Yeah, some of them are sharing the feedback in the chat box.
Yes, sir. Thank you, Sandeep. Thank you so much. You guys can stay in touch, I would like to say, because there are a lot of things that we are not able to share in a session. And also, as a teacher, I'm may or may not be allowed to make mistakes. I was making a mistake somewhere. You corrected me. So it's a two-way process. Learning is a two-way process, I guess. So help me learn and learn from me. I will say, please be active in the group and tag me in the group because I usually don't see the chats. So if you have any doubts regarding any new concepts that you read in ordinary differential equations, please tag me and you can ask. You can stay connected there.
Okay, thank you.
Especially the session is very good one. Especially you put the problems related to this orthogonal trajectories and the problems related to this autonomous differential equations. And I am now only understand what is this equilibrium points and all. So it is very useful to me. Very nice one.
I would say don't end the concept of equilibrium points here if this was new to you, because this was just a beginning. You saw one question. I will give you 4 or 5 questions, no doubt, but follow this topic and make a command over it. Okay?
Thank you.
Yeah, sure.
Thank you, Arunachala Bhupati. Could you introduce yourself? Where are you from?
I am from 𝐷𝐬𝐭𝐡, near Madurai. I am working as a school teacher.
Okay. Okay, thank you, Arunachala Bhupati.
Thank you, sir.
Okay. So, Unnati, once again, thank you from my side for everything, for being with Math Aspirants.
Thank you, sir.
And,
It is always a refreshing experience. Thank you, sir.
Please do share the PPT of this session along with the workout, and you can adjoin more problems if possible for them to practice.
Sure.
We can share it with the recording of this program.
Okay, sir. Sure.
Okay. Thank you. Thank you, everyone. Let us wind up here. Bye.
Okay. Bye-bye, everyone.
Yeah.